Hello friends, in this video, we are going to learn the relationship between 2D array and pointers. Let us take an example of a 3x3 two-dimensional array. The base address of this array ARR is 1000 and its memory address is an arithmetic progression with common difference of 4 as this is an integer array and size of an integer is 4. Here, address of array that is ampersand ARR is a pointer to the whole 2D array. Here, it is a 3x3 array. So, ampersand ARR is a pointer to the whole 3x3 array. And we can denote ampersand ARR as a pointer of type int star of 3x3. It simply says ampersand ARR is a pointer to a 3x3 integer array. So, the base address of the 2D array is 1000. So, ampersand ARR value will be 1000. And what will be the value of ampersand ARR plus 1? If we move a single integer pointer, it will point to the next variable's memory address. But here, ampersand ARR points to the whole 3x3 2D array. So, if we move ampersand ARR by one position, that is ampersand ARR plus 1, it will point to the next 3x3 2D block, that is a 3x3 block. So, the address of next 3x3 2D block is 1036. So, ampersand ARR plus 1 value will be 1036. Now, let us understand about ARR. ARR is a pointer to the first 1D array. Here, 1D array has 3 elements. So, ARR is a pointer of type int star of 3, which means ARR is a pointer which points to an array of 3 integers. So, the first row's base address will be stored in ARR. And here, first row's base address is 1000, so ARR value will be 1000. And since ARR is a row pointer, if we move ARR by one position, it will point to the next one-dimensional row. So what will be ARR plus 1? It will point to the second row of the 2D array. So ARR plus 1 will be the base address of the second row, that is 1012. Similarly, ARR plus 2 will be pointing to third row and will have the address 1024. Let us understand about star ARR. Star ARR will point the first element of the 2D array. And it is a pointer of type int star as it is a pointer to a single integer element. So if we write star ARR, you will get the address of the first element of the 2D array, which is 1000. As star ARR is a single element pointer, if we move star ARR by one position, it will point to the next element. So star ARR plus 1 will be the address of next element, which is 1004. Similarly, star ARR plus 2 will be the address of the next element, that is 1008. Finally, star ARR will be the value of the first element. Since star ARR holds the address of the first element, star ARR will give the value stored in the first element. And if we move star ARR by one position, that is star ARR plus 1, the value will be incremented by 1. And if the first array element is 10, star ARR plus 1 will be 11. Now, let us summarize the concept. Here, ampersand ARR is a 2D array pointer, that is of int star row of column. So, ampersand ARR plus 1 will point to the next two-dimensional block. Next, ARR is a 1D pointer, that is of type int star of row. So, ARR plus 1 will point to the next one-dimensional array in the two-dimensional array. Next, star ARR is a single element pointer, that is of type int star. So, star ARR plus 1 will point the next element in the array. And finally, star ARR is the value of the first element. So, star ARR plus 1 will increment the element value by 1. So, let us connect this with a real-time example. If we assume this building as a 2D array and it has 4 floors and 3 houses in each floor, then ampersand ARR will point the entire apartment, that is, it will point building 1. And ampersand ARR plus 1 will point the next apartment, that is building 2, which also has 4 floors and 3 houses in each floor. And ampersand ARR plus 2 will point to the next apartment, that is building 3. And ARR will point to the first floor, that is top floor of building 1. And ARR plus 1 will point to the next floor. and star ARR will point to the first house of this first floor, and star ARR plus 1 will point to its next house, and so on. So in a 2D array ARR, ARR can point to the whole 2D array and a single row and a single element also.